Okay, in this video I'm going to have a look at duration. I've got here duration 1. I'm going to look at changing the duration maps in the same SAT Layout 1.9 EDC16 file that I've been using for all of the EDC16 videos. And basically what I've done is I've copied, there's the map. I've copied the map from the file. It's already got factors sorted, so in other words it's actual duration figures rather than raw data. And then I've put the axis data for injection quantity across the top and axis data for revs per minute down the side. And then I've just cheekily extended it right out to 85, which is obviously ridiculous, but I've just done that there. And then I've created an exact copy of the chart in the sense that I've still got revs per minute down the side, and I've still got injection quantity across the top, and I've still got it extended as I had it before. But what I've put in here is the same figures, except that I've divided those figures by the amount of fuel being injected. So in other words, 4.4 there is 2.2 divided by 0.5, which gives me 4.4. And if I go over and look over here, I've got 18 divided by 60, which gives me 0.3. Now the reason I've done that is so that I can look at what's happening, because if I look at what's happening here, if I look at 60, I can look at the way this column is gradually getting bigger and bigger and bigger and bigger and reaching what you could call a maximum. So it's reaching a maximum value, or a maximum number of degrees divided by injection quantity. And if I look at the number of revs per minute, if I look at the maximum revs per minute, the number is, ignore some of the silly numbers at the beginning, but it's basically falling. So in other words, it's falling, but it's reaching that same point there in the corner there. So here I've got in the corner a maximum or a minimum, depending on how you look at it, because if you've gone that way it's a maximum, and if you've come this way it's a minimum. But what we've got here is the number of degrees per milligrams of fuel. So this is the number of degrees it takes to inject that amount of fuel. Now I'm interested in this, and obviously you don't need this for remapping, but you do if you want to get a clue as to what figures you should be considering. Because I'm saying to myself, well, okay, what if 0.73 is the maximum per milligrams? If 0.73 is the maximum per milligrams, in other words, roughly 44 degrees is the maximum per milligrams, then 44 divided by 60, which is 0.73, is the maximum that the injectors in this engine can ever manage. Now I can't know that for sure, and Bosch don't make this sort of information available very readily, so I have to assume that I am close to that maximum, because I have to assume the designers decided to make the file and the maps that way. So what I'm going to do is I'm going to take those figures and assume that the figures in the last column do not increase if you change the fueling. I'm going to assume that those figures stay the same if you change the fueling, because I'm going to assume they are already the best you can get. Now at this point right in the corner here, I might well be correct, and that is the best you can get for these injectors. Elsewhere on here, that will almost certainly not be the case, but as I can't sit here and calculate carefully each of these values for myself, I'm simply going to use those. So what I'm going to do is I'm going to copy those and I'm going to paste them in here. Now don't be too surprised if this goes haywire, because it often does. There we go, just ignore that. Tell it that what we want is the values and the formatting, and it's accepted that. Just delete that highlight there. Right, so these then are all the same. So in other words, I'm saying for 65 I want exactly the same values. Now the reason I've done that is purely because I want to use these values in a calculation up here. Because what I've done up here, if I click on there, you'll see what I've done. what I've done is I've taken the value that's in R6, so in other words that number there, the IQ 65 injection quantity, so I've taken that value and I've multiplied it by the R31, which is the value down here, and it's given me an answer of 19.5. So in other words, whereas on the previous one 60 times 0.3 was 18, 65 times 0.3 is 19.5. And now again I've still got 30, so I've got 70 times 0.3, sorry I called that 30, and that's now giving me an answer of 21. And I've got 75 times 0.3, which is giving me an answer of 22.5, and so on. And then what I'm going to do is I'm going to pull across to here and I'm going to drag those down so that I get the complete set all the way across. Now the figures that result from this are complete nonsense, and they're complete nonsense not because they're nonsense figures, but because they will probably go way off the scale for the injectors for this engine. Now it would not surprise me if the injectors are already maxed out in this engine at around about 44 degrees, because that's a very high number for duration. So it's quite possible that this engine is very close to its maximum of 60 and at 44 degrees. But what I've done is I've assumed it's not, and I'm taking these figures, and so now I'm saying to myself, well, if I want to inject 65, these are the duration values that I should use. And so if I wanted to use these values, then all I would do is I would get rid of a column somewhere in here. I would probably say to myself, well, I can probably manage without 7. So I would delete column 7, all of it, and then I would shift all of this across into 7's place. Now I'm not doing that at the moment because I don't want to risk disturbing any of the calculations. And then of course once I'd shifted all these across, 60 would now be in there, and that would leave me room to put 65 on the end. So I would have 65 as a new column on the end, and 7 would be gone, so the whole map would be the same size as it was originally. So that's one way that I can do this. Now, one of the things about this is that it's a good idea to check to see if what you've done has made sense. Now, I'm hoping that anyone watching this knows how to turn this data into a graph, because what I've done is I've picked various points on here and turned them into a graph. And if I go down here to the graph, this is all of the data from here on a graph. So in other words, it's the original block plus 1, 2, 3, 4, 5 extension points. Now I've deliberately done that because if we look at what's happened, we can look at our 1, 2, 3, 4, 5 extension points, and we can say to ourselves, do these make sense? Now I would suggest that they don't make sense. In other words, if I was to be looking at, let's say, this line here, it gets to about there on the original, and then it's taking off in a straight line with my changes once it gets higher. Now I don't suggest that that's accurate. In other words, I'm suggesting that this maybe wanders across here somewhere, if it exists at all. And if you look at this one again, if we look at 5,000, 5,000 was coming along like that until it got to 60 here, and then I've taken it up like that. But if I was to look at the shape of that graph, I think it's curving across here. In other words, I think this is going to plateau out. So I don't think that that number there, which is the first, my new one, my new 65, I have severe doubts that this is actually possible. Because as I said earlier, it wouldn't surprise me if 60 milligrams at 5,000 revs is already maxed out at 44 degrees. Now the reason for this is simply, can the injectors flow any more fuel? Because if the injectors can't push any more fuel through, and 44 degrees is about the maximum that the injector can bear to stay open, because either it will have been held open too long by the injector voltage, or we will be too near the end of the camshaft pressure zone, then we would be stuck and we wouldn't be able to go any longer than 44. So it wouldn't surprise me, looking at this file, if we found that we can't get much more than 44. It might be worth testing to see if we could manage 65, to see if we get an improvement in performance in any way. But certainly, looking at this, 60 seems to be very close to the maximum already in this file, which is why at the beginning I said these figures are plain daft. Now, the injectors in this engine theoretically could probably flow up to about 85, which is why I extended this to 85. But you can see in reality whether they can reach 85 or not doesn't matter, because if the maximum duration turns out to be somewhere in the region of 44 degrees, which it wouldn't surprise me if it is, then the rest of these figures cannot exist. Because if you cannot get a duration of 62, then you're not likely to get fueling of 85 milligrams. You can only find out the exact answers to this on the rolling road, because the only way to know exactly what is going on would be to load in 65 milligram maximum map and test the performance on the rolling road to see what the exhaust and the power and etc. are actually doing. There is no real other way of doing that. Right, I'll stop there at that point, having shown you how you can or maybe cannot change duration depending on your file.